When astronomers look into deep space, they are often searching for faint points of light that barely move against the backdrop of distant stars. Most of the time, these are asteroids or comets from within our own solar system. Every now and then, however, something much rarer comes along. An interstellar visitor, a body that did not form here but comes from another star system entirely. Only two of these have ever been confirmed by the astronomical community. The elongated object named Oumuamua, discovered in 2017, and Comet 2I/Borisov, identified in 2019. Both sparked intense debate and curiosity because they challenged the way scientists thought about planetary formation and the movement of small bodies across the galaxy. It is against this backdrop that reports began to circulate about a third such object. Amateur astronomers, using advanced but accessible equipment, were the first to track it. For months, they recorded images and compared notes online. The object became known informally as 3I/Atlas, a name referring to it being the third interstellar object confirmed, with Atlas taken from the telescope survey that had first detected it. In many ways, the story echoed what happened with Oumuamua, an unusual discovery that did not fit neatly into existing categories, drawing in both amateurs and professionals to observe it more closely. One of the early figures in this story was an astronomer named Leslie Peltier. Although not part of a major institution, Peltier had access to professional-grade equipment, including a research telescope measuring 40 inches, fitted with a cooled CMOS camera to improve sensitivity to faint light, and a tracking system connected to NASA's ephemeris data. This meant he could follow the movement of the object with high accuracy, correcting for Earth's own rotation and orbital drift. Initially, nothing about the observation seemed especially unusual. 3I/Atlas appeared to be a fast-moving body, displaying the expected greenish glow from its tail, which was likely caused by gases such as carbon monoxide and nickel becoming excited by solar radiation. In short, it behaved much like an interstellar comet. This changed dramatically on the 19th of September, when Peltier captured images that seemed to show something extraordinary. Around the central streak of the object, he recorded 9 smaller points of light. They were faint but distinct, and in his frames, they moved in perfect synchronization with the main body. The pattern was striking. They resembled fireflies orbiting a lantern, evenly spread around the larger central glow. Unsure what he had actually recorded, Peltier posted the images to several online astronomy forums. At first, most of the responses from professionals dismissed them as imaging noise, cosmic rays striking the camera sensor, or simple processing errors. These are common problems when photographing very faint objects near the limits of a telescope's capability. But Peltier was not the only one watching. Over the next 2 days, several of the world's most advanced instruments were turned toward 3I/Atlas. The James Webb Space Telescope, the Hubble Space Telescope, the Very Large Telescope in Chile, and the KK Observatory in Hawaii all made observations. These facilities are designed to measure galaxies billions of light-years away and detect incredibly faint signals. When their results came back, they confirmed the same thing that Peltier had seen. 9 distinct companions were moving in lockstep with 3I/Atlas, and their signatures appeared consistently across multiple independent instruments. At this point, what had seemed like an amateur's anomaly became a verified astronomical event. The confirmation created immediate concern and fascination. Spectral data showed that all 9 objects shared the same trajectory and velocity as the main body, which strongly suggested they were connected to it in origin. They also displayed the same unusual green-tinted tail, confirming that their emissions were not simple reflections of sunlight, but driven by the same chemical processes as 3I/Atlas. In short, this was not a simple case of unrelated bodies passing near one another in space. Instead, it looked as though 3I/Atlas had somehow multiplied into 10 distinct but related objects. The chemistry was also puzzling. Analysis revealed that the companions had metal-rich signatures, including nickel, cobalt, and certain alloys that are typically associated with very high-temperature processes. These are not unknown in astronomy, but the way they were concentrated in relatively small bodies made scientists take notice. Even more concerning was the inferred energy output. Observations suggested that 3I/Atlas was already producing about 10 gigawatts of thermal energy, based on its glow and tail behavior. This figure was unusually high for a body of its size, but still within the range that might be explained by exotic chemistry. The 9 new companions, however, each seemed to produce around 20 gigawatts on their own, despite being estimated at only about a tenth of the size of the main object. To put these figures in perspective, the largest nuclear power stations on Earth, such as those in France and China, generate only a few gigawatts of electricity. They also require thousands of tons of infrastructure, fuel rods, containment vessels, and coolant systems. Yet here were city block-sized bodies, producing many times more energy without any visible external structures. The numbers simply did not add up. Fusion on that scale, inside such small objects, should be impossible by the standards of current physics. Attempts to model the scenario using supercomputers at institutions like MIT and Caltech repeatedly failed. No matter what parameters were entered for temperature, plasma density, or pressure, the equations refused to converge. It was as though the physical model itself broke down when applied to these objects. This led to speculation. Some theorists suggested a hybrid of fission and fusion reactions. Others considered the possibility of antimatter catalysis, or even processes involving dark matter. All of these, however, remain purely hypothetical, and none provide a convincing explanation for the stability observed in the companions. If they were undergoing uncontrolled fusion or antimatter reactions, they should have torn themselves apart instantly. Yet they continued to travel smoothly, in formation, without signs of disintegration. Another mystery lay in the timing of their appearance. For months, both professionals and amateurs had been watching 3I/Atlas carefully, and none had reported any sign of additional bodies. The sudden emergence of 9 companions, all at once, raised questions about whether something dramatic had happened in mid-September. Teams led by Avi Loeb at Harvard analyzed the timing and concluded that the companions appeared at 2 a.m. UTC on the 19th of September, and that the process itself lasted no longer than 1/10 of a millisecond. That is far faster than the blink of a human eye, which takes around 300 milliseconds, and even faster than a camera flash, which is about 5 milliseconds. The event was so quick that no existing telescope or spacecraft had the temporal resolution to capture the actual moment. They simply appeared in the images as if they had always been there. Astronomers often caution against jumping to conclusions, and this case was no different. Natural explanations were put forward. One possibility was that 3I/Atlas had collided with another body, shattering into pieces that continued along the same trajectory. Given its estimated velocity of around 60 kilometers per second, such a collision could, in theory, produce multiple fragments with enough kinetic energy to glow brightly. But critics noted that such fragments would not likely display the same energy output as the original, and certainly not a greater one. Nor would they produce perfectly synchronized tails with identical chemical signatures. Instead, the scenario pointed to something more complex. While public statements from space agencies such as NASA and ESA remained minimal, the discussion in scientific circles grew more animated. Some drew comparisons to Oumuamua, which also defied easy classification. Others emphasized that interstellar objects are by definition unusual, and that humanity has observed only a handful of them. It may simply be the case that 3I/Atlas is revealing a category of body we have not yet encountered. The universe is vast, and our sample size is extremely small. What is clear is that the sudden appearance of 9 companions, their unexpected energy signatures, and their coordinated movement turned 3I/Atlas into one of the most closely watched objects in the sky. Observatories worldwide adjusted schedules to prioritize tracking it. Space-based instruments continued to record data, while amateur astronomers contributed valuable imagery from different locations on Earth. With October approaching, when 3I/Atlas would reach its closest pass by the Sun, there was a growing sense that time was short. Whether the companions were natural fragments, the result of exotic chemistry, or something entirely different, they represented a phenomenon that science could not yet fully explain.